If you are a coder, you are often required to do asymptotic time complexity analysis of algorithms. The time complexities are often log n and n log n. In order to understand n log n and log n, you need to understand logarithms. Mathematicians always invent convenient notations for mathematical operations. For example, same number additions like 2 plus 2 plus 2 can be written as 2 times 3, which means 2 added 3 times or simply 2 times 3. Likewise, 3 plus 3 plus 3 plus 3 would mean 3 added 4 times or simply 3 times 4, and we can write it as 3x4, x means multiplication. Few more examples. 5 plus 5 means 5x2, 5 added 2 times. 6 plus 6 plus 6 means 6 multiplied by 3, that is 6 added 3 times. 10 plus 10 plus 10 plus 10 plus 10 is equal to 10 times 5. So far so good. But what if, similar to the same number addition, we want to represent same number multiplication? Say, we want to multiply 2 or 5 times. We can always write 2 times 2 times 2 times 2 times 2. Well, 2 times 2 times 2 times 2 is a good notation, no worries. But what if we want to multiply 2 1,000 times, or 100,000 times, or even 1,000,000 times? Writing 2 times 2 times 2 1,000,000 times is surely not convenient. So mathematicians invented another way of representing same number multiplication. 2 times 2 times 2 can be represented as 2 with a 3 on the top of 3. This is called exponentiation notation and is said as 2 is raised to the power 3, or simply 2 to the power 3. So 3 times 3 can be written as 3 to the power 2. 2 times 2 times 2 can be written as 2 to the power 3. Or any number b multiplied by itself 3 times can be written as b times b times b, or b to the power 3. Number b, when multiplied by itself 2 times, can be written as b times b, or b to the power 2. 3 times b multiplied by b multiplied by b, or b to the power 3. Or 4 times b times b times b times b, or b to the power 4. P times, so b multiplied by b multiplied by b, a p times would become b to the power p. So to generalize, a number when multiplied by itself a p times is called b to the power p and is written as b with a small p on the top of b. The result of multiplication is called product. So the product of 2 multiplied by 2 is 4 and the product of 2 multiplied by 2 multiplied by 2 is 8. Let us call the product of b multiplied p times as n. Or b to the power n. When we raise b to the power p, we get n. So given a number b and a power p, we can find n. But what if we are given b and n? Can we find the power? Say we are given b as 2 and n as 8. Let's put the number in the b to the power p form. We are given b as 2 and n as 8. So we can write it as 2 to the power p is equal to 8. That is to say, if 2 is raised to the power p, we will get 8. Or how many times do we multiply 2 by 2 to get 8? Let us see. 2 multiplied by 2 is 4 and 2 multiplied by 2 multiplied by 2 is 8. Or we will have to multiply 2 or 3 times to get 8. So logarithms means that power p. Ask a question, what power p of number b would give us the product n? Here I know b and I know n, but I don't know the power. That is, b to the power what is equal to n. I can also ask the question b to the power what is equal to n in a mathematical way. In a mathematical notation, it is written as log of n to the base p. In this notation, b is called a base. Let's do some simple logs to the base 2 example. Log of 4 to the base 2 means How many times to multiply 2 to get 4? Since 2 multiplied by 2 is 4, log of 4 to the base 2 is 2. Similarly, log of 8 to the base 2 would be 3, as 2 multiplied by 2 multiplied by 2, that is 2 multiplied by 3 times, is 8. And log of 16 to the base 2 would be 4. Let's do some more example. What is log of 100 to the base 10? It would be 2, as 10 multiplied by 10 is 100. And some more examples. Log of 64 to the base 2 would be 6, and log of 64 to the base 8 would be 2, because 8 multiplied by 8, that is 8 to the power 2, is equal to 64. Now that you know what is logarithm, here is some general knowledge. Most commonly used bases for logarithms are 10 and a numeric constant e, also known as Euler's number. In fact, 10 and e bases are so common that when writing log of n to the base 10, base is often omitted. So if you see simple log of n expression, it means it is log to the base 10. Similar to log of n to the base 10, log of n to the base e is so common that it is often abbreviated as ln of n, where ln means natural logarithm. Hey there! Now that you have mastered logarithm, let us learn some logarithm identities. So log of 1 to any base will always be 0, because any number b raised to the power 0 is always 1. Log of b to the same base is always 1. Now log of x multiplied by y to the base b is equal to log of x to the base b plus log of y to the base b. Similar to that, log of x divided by y to the base b is equal to log of x to the base b minus log of y to the base b. Log of x to the power d to the base b is d multiplied by log of x to the base b. Change of base. Let's change log of n to the base b to a new base k. So log of n to the base b can be specified as log of n to the base k divided by log of b to the base k. Now I'm leaving you with a question. The Windows default calculator has a log button. We know that when we specify just log without specifying base, it means log of 10. Now using just Windows calculator, which is log of 10, can you calculate log of 10 to the base 2? Share your answers and how did you find in the comment sections below. If you like my videos, please hit the like button, don't forget to subscribe and press the bell icon to get the updates from this channel. Thanks for watching TechUcity.